All right, so for the negative case, we do f of negative x, which means we have to put in negative x for every single x. So that's going to be negative x to the 4 minus 3 times negative x cubed minus 5 times negative x squared. I'm going to do it like this one time, and then from now on, we're always just going to find a pattern and do it with a pattern. Plus 2 times negative x plus 7. Now, remember, even exponents get rid of the negative, right? So here we have positive x to the 4. Is the next term going to be negative or positive? Positive 3x cubed minus 5x squared minus 2x plus 7. Now, so this is f of negative x. Let's compare the original with f of negative x. Look at x to the 4. Did it keep the sign? Yes. X cubed, did it keep the sign? No. X squared kept the sign. X to the 1 didn't keep the sign. The constant kept the sign. So which terms did not keep their sign? Did not maintain their sign? The odd ones did not maintain their signs. So the next time we have to do this, then we can skip that first blue step, and all I do is I look at this. Whichever one has an odd exponent, I just switch the sign. Okay? Okay. Now we're going to do the same thing. Go down this row and see how many variations of sign there are. The first coefficient is positive, positive. Ooh, here it changes to negative, 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 and then here it changes to positive. Okay, so number of negative ones then is again 2 or 0. Are we okay with this? Yeah.
So if there's 0 negative.
Okay, I'm not. Okay, yeah.
Does that mean that there's before?
Okay, hang on. I'm not there yet. I'm not there yet. Yes.
When you were doing the negative 3 negative x to the third, why does that change?
Because negative x cubed is negative times negative 3 is positive.
And then negative is
Positive times negative is okay. Now what we have to do is we have to make a chart. Yes.
For the negative, you also do the same thing.
So now we need to make a chart, and the chart will look like this. We need to make a chart with 3 columns: positive, negative, imaginary. Okay. Huh? We've done this in algebra 2. So now, here's what you're going to do. You have to match each one of the positive ones with each one of the negative ones. All right? So look at how we do this. If you have 2 positives, you have to match that green 2 with each one of these blues. Okay? So 2 matches with a blue 2. A 2. And it matches with a blue 0. Okay? I'll write it in a different way right now so you guys can see it. And then this 0, you have to match it with a blue 2 and a blue 0. So 0 with a 2, 0 with a 0. Basically what I'm doing is this. The number of positive ones, you have 2 and 0, right? The number of negative ones, you have 2 and 0. What you have to do is you have to match this 2 with each of those. And then you have to match this 0 with each of those. So you have to take all the different combinations. Okay? All right. So now, look at what this tells you. Each of these rows each row has to add up to the degree. What's the degree here? 4. So look at this one. 2 plus 2 makes 4. How many is left over to make 4? 0. So you put 0 there. 2 plus 0 is 2. How many more do we need to make 4? 2. Here, how many more do we need to make 4? 2. And the last one? 4. Okay, so let's recap. Rows, so each row should add up to the degree. Okay, in this case it's 4. Look at this last column, the imaginary column. That's not an imaginary column. It's the column of imaginary numbers. What do you notice about the numbers in there? Are they even or odd? Even. They're all even. So here's the thing about imaginary numbers. They never travel alone. They always travel in pairs. You can never have 3 imaginary solutions. Nope, never. Never have 5. It's either 2, 4, 6, 8, or 100. Okay?
Not that.
Possibly. No, I'm kidding. It's just all even ones. So this one must all be even. Okay? So what does this tell you? This has 4 solutions, right? So one scenario is it could have 2 positive and 2 negative. Another one is it could have 0 positive, 2 negative, 2 imaginary. So here is a question. Is it possible for this function to have zeros like this? So is it possible that the zeros of this function are 1, 2, negative 3, and 5? Is that possible? No. Because there is no way that this will have 3 positive zeros and a negative. Right? That's what this is for. Okay, let's do another one. We're going to do this one like much quicker. Okay, so number of positive zeros. How many variations in sign? So let's see, 1 here, 1 here, and 1 here. So 3 or 1. Okay, now let's take f of negative x. Everything with an even exponent is going to remain unchanged. The ones with odd exponents are going to switch signs. So, negative 11x to the 4, negative 20x cubed, positive 3x squared, positive x, positive 18. How many times did this change signs? 1. So the number of negatives, 1. So let's do a chart. Positive, negative, imaginary. Okay? We're going to match the purple 3 with the 1. The purple 1 with the 1. All right. How much do they add up to? So this one they need to add up to 4, right? So 3 and 1 is already 4, so we don't need any more. And then here we need 2 more. All right? What happened here? Okay. All right. So let's talk about complex zeros. Yeah.
The odd exponents are the ones that don't change their sign. When they do change their sign, and the number of negative zeros is how many change, right? So
no, that's the thing. Not how many changed. After you do f of negative x, you go down this row and see in this line how many variations are there. So negative, negative, positive, 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 positive. It's not from here to here. That's always like that's always a source of confusion, and I'm always like sort of careful of how to use my language, but I always kind of like follow this. It's once you've figured out f of negative x, now you throw this one away, and just for f of negative x, you go down the list, or you go down the row, and see, okay, negative, negative, here it went to positive, and then it stayed positive. Okay? Any other questions? So this is a corollary. Basically, all this says is the degree n means something has exactly n zeros, including positive, negative, real, imaginary, everything, like everything. Okay? All right. So what does that mean? That means once you factor a polynomial, okay, if there are n zeros of a polynomial, that means there have to be n factors. Okay? All right. So, what about those factors? If a function has real and imaginary zeros, we call those complex zeros, right? A function will have complex zeros when it has a quadratic factor which has no real solutions. Okay? Okay, let's look at an example. So suppose you had some f of x, blah, 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 blah. And now we factored f of x. And we factored it and we got x plus 7, x minus 5, and x squared plus 2. Okay? Can I factor this some more? No. Can I factor this anymore? No. Can I factor that anymore? No. But what type of function is that? Starts with a Q. It's a quadratic function. Can I reduce it anymore? No. This is a quadratic factor which cannot be reduced anymore. It is called an irreducible quadratic factor. When you have one of these, what happens if you solve that? What happens if you set that equal to 0 and solve? You get an imaginary number. That's when you get complex or imaginary solutions. Okay? Cool. Okay. So look at what it says here. It says write this. Sorry, Miss Casey. I guess that was a student that needed something from me. Okay. It says write as a product of linear and irreducible quadratic factors. Okay. Which means first we need to factor. Okay. All right. No calculator. It's x to the 5 plus x to the 4. This is like one crazy looking function, right? And I have no calculator with me. So what am I going to do? P's and Q's. Okay, so if you're ever like lost on a desert island with no calculator, what are you going to do? You could just randomly make up a problem like this on the sand and start factoring. Okay, so, all right, so what's P gonna be? P, okay, so look, let's do a little bit of a mental exercise. P is going to be all the factors of 24. Q is going to be all the factors of what? 1. And then I'm going to do P over Q. But if Q is 1, you might as well just do P, and that'll be your P over Q. Okay? So, P over Q is going to be plus or minus, right? So this is a 24. Ignore the negative. And here we had a 1. So you can do this when, you know, that leading coefficient is a 1. Okay, so what are the factors of 24? 1, 2, 3, 4, not 5, but 6, 24. Okay? So, and then if you go, like here, it's 4 times 6, 3 times 8, 2 times 12, 1 times 24. Okay, so here's what you're going to do. How many numbers in this list? 16, because the plus or minuses. So now what we have to do is we have to take every single one of these and do synthetic division until we find one with the remainder of 0, because that's what tells me it's a 0. So there are 5 possible zeros here. If they were rational numbers, they would be from that number, from that 16. So 5 of those 16 are potentially zeros of this function. So until you find one that's 0.
Oh, until I find one.
So now what you can do,
Why is it one and not five?
little tips and tricks. You can use Descartes' rule of signs to narrow it down further, because what if Descartes' rule of signs says 0 positives? So then you can just all try the negatives, right? Ah, that's why we learned Descartes' rule of signs. So, or you can try your, okay, so you could go in order 1, -1, 2, -2, 3, -3, or you could say, you know what, I'm feeling lucky today, and just go at it at random, and you know, maybe it'll work. Let's do that. I'm going to pick a random number. I'm going to pick -2. Okay? Let's do -2. Okay, let's see the exponents here. 5, 4, 3, 2, 1, 0. Yep, yep. So 1, 1, -13, -23, -14, -24. Okay, 1 comes down. I picked a random number. I just closed my eyes and just picked the number. -1, 2, -11, 22, -1, 2, -12, 24, 0. Oh my word. How lucky. It's my lucky day. Okay. So, shh. This is actually the one day to not get a lottery ticket, because whatever luck I had, I just squandered it on this one. So statistics says it won't happen twice in a day. So that's it. I should have just bought the lottery ticket before. No. Okay. All right. So now we're going to write the factors of this. The -2, if the -2 is a 0, that means x plus 2 is a factor. The depressed polynomial will give us x to the 4 minus x cubed minus 11x squared minus x minus 12. Okay, that's it. Yes. So now x to the 4, I can't factor that by hand. So now I have to do synthetic division with this one. Now, a few tips and tricks. If this list of zeros, right, worked for the entire polynomial, then this will have factors that are included in this. So you don't have to do a new P and Q. However, is 24 going to be a factor of this blue one? No. So this is a smaller, it's a subset if you want number theory, okay? So you could go back here and try ones that you haven't tried yet, okay? So we're going to pretend we tried 1 and -1 and 2, and -2 worked, okay? Let's go to 4. Let's see if 4 works. So we have 1, -1, -11, 1, 4, 3, 12, 1, 4, 3, 12. We get 0. Hey, That works. Question for you. If I had picked randomly the 4 first in the purple and then the -2, would all this still have worked the same exact way? Yes, it would have. Okay. So now, here's where bookkeeping is super important. This x plus 2, you have to carry it down. And then I have x minus 4. And then from here, I have x cubed plus 3x squared plus x plus 3. Now, when you get it down to a cubic term, there is a possibility that you can factor by hand. If you have a cubic term and 4 terms, then ask yourself, can I factor by grouping? Okay? Sometimes it's not obvious to see, so you have to literally like try it out. Sometimes it's a little bit more obvious to see. If you have a repeating pattern in your coefficients, you know for sure you could factor by grouping. Like look at this green one. My coefficients are 1, 3, 1, 3. Okay? If it's like 2, 5, 2, 5, 3 minus 2, 3 minus 2, factor by grouping. Okay? So let's factor by grouping here. X plus 2, x minus 4, and then here I can factor out an x squared and I get x plus 3 plus, it's an x plus 3, so I can write it as 1 times x plus 3. Okay, so I now have x plus 2, x minus 4, x plus 3, that's that common term, x squared plus 1. Okay, there we go. I factored it. I can't factor that anymore just yet. So you know what? I'm just going to copy it over here. I have x plus 2, x minus 4, x plus 3, x squared plus 1. Let's see what the instructions said. The instructions said, this is it. This is factored now. Let's see if it meets the criteria. Write kx as a product of linear factors. Look at this. Linear factor, linear factor, linear factor. And irreducible quadratic factors. This is an irreducible quadratic factor. So there we go. Okay? So it's okay to stop now because we have written it in terms of linear and irreducible quadratic factors. So next part, we're going to go further. In the next part, it says write kx as a product of all linear factors. Okay, so this is linear, this is linear, this is linear, not linear. I need to figure that. I need to factor that one. So think about this for a minute. This is x squared plus 1. What is the reason why I can't factor this? What's the positive is standing in the way. So if it was x squared minus 1, I could have done x minus 1, x plus 1, right? So the thing is there has to be a negative here, right? Okay. What if I can rewrite this as x squared minus something? X squared minus what would be the same as x squared plus 1? Negative 1. Yes. Now, how do I factor this one? How do I factor this one here? Okay. Right, but why? Suppose it was x squared minus 4. What do you do? X, and then what do you do to the 4? Yeah, but what do you do to get 4? You take a square root. Okay? So here, x, it's minus negative 1 because it came from the plus. Okay, so the plus, we rewrote it as minus minus. Now, if in here I want to put the square root of negative 1, right? square root of -1, square root of -1, and then plus or minus. So finally, what does that give me? X plus I, X minus I. Okay? So finally, Kx, K of X is, from before, X plus 2, X minus 4, X plus 3, and then X plus I, X minus I. You see that? What was the degree? 5. That means it has to have 5 linear factors. Count them. 1, 2, 3, 4, 5. Okay? Question? Yeah.
So let's just say you get this problem on test.
Uh-huh.
We're not so lucky as you.
I'll talk about that. So now list all the zeros. It's going to be, so X is -2, 4, -3, plus or minus I. Okay? All right. Write a polynomial function with at least, write a polynomial function of least degree with real coefficients in standard form that has cube root of 5 as a 0. Okay? All right. How do we get cube root of 5 as a 0? Right. So the way we got cube root of 5, okay, so if I have x minus 2 equals 0, then x is equal to 2, right? If I have x squared minus 2 is equal to 0, then what's x? X squared equals 2. X is plus or minus root 2. So now if I wanted to get, so this x squared gives me a square root. So if I wanted to get a cube root, then it would have to be x cubed. So it would be f of x is equal to x cubed minus 5. Okay? And if this shows up on a test or a quiz, I'm not really looking for any work because, you know, it should just be a mental thing. And then it's either right or wrong. Okay? So if you want to check, right, x cubed minus 5 equal to 0, sure enough, x is cube root of 5. Okay? Now, take a look at this one. Write a polynomial function of least degree with real coefficients in standard form that has all of these as zeros. So I have -1, 2, and 2 minus I. Okay, so here's the deal with these imaginaries. Remember how I said they always come in pairs? Yeah. They come in conjugates of each other. So if 2 minus I is a 0, then so is 2 plus I. So you have to change the sign of the imaginary part. So if 2 minus I is a 0, then also 2 plus I. Okay, so then what is f of x? F of x is x plus 1, x minus 2, and then x minus 2 minus I, x minus 2 plus I. Okay? Okay. Now, here's what we're going to do. Let's just multiply this out first. Okay, we're going to get x squared plus x minus 2x. It's minus x minus 2. Okay, let me show you a trick with this one. Distribute the negative here and here. So I get x minus 2 plus I, x minus 2 minus I. I just distributed the negative. Now look. The associative property of addition says you can group, if you have three things that are being added or subtracted to each other, you can group them in any combination. So I'm just going to put in parentheses here and here. You know why? Because I can. That's all. But now, look at what happens. Now I have the parentheses plus I, the parentheses minus I. So I have something plus I, something minus I. A plus B, A minus B. Okay? Huh? They don't cancel, but it's x plus 3, like x. So if I had like x plus 3, x minus 3, right? Then what would happen? I would square this, and I would square this, and put a minus in the middle. So that's what we're going to do here. Now I have A plus B, A minus B. So let's see what we have. Here I have x squared minus x minus 2. And then here I have the first term squared. And then the second term, I squared, with a minus in the middle. Okay. What's this? When I square, x squared minus 4x plus 4 plus 1. Do you guys believe me that that's a plus 1? Okay. So this is, so f of x is x squared minus x minus 2, x squared minus 4x plus 5. And then I'm not really going to do it. I'm going to leave it for you guys to do. You would have to like multiply that out. Yeah, I know. Nope. We're going to move on to bigger and better things. Okay. So, the question of, when we had to pick, one of the zeros, and then, it's very time consuming, right? One way to get around it on my tests, let's say, is I will give you one of the zeros to start with, and then you just have to continue with that one. Or I'll show you another way later. But look at this one here. So we can apply the same thing here if you're given, wait a minute, this one, sorry. Oh, sorry, I have it in different order here. All right, I'll move on to the next one later. So look at this one. We want to do synthetic substitution same way, but now with x cubed minus 3, right? So we want to write the polynomial as a product of linear and irreducible quadratic factors, blah, blah, blah. Okay, so let's do this. What if I do P and Q here, right? What does that tell me? What are the zero? What's P and Q? I get plus or minus 1 and 3. Okay, so it turns out none of those are zeros of this. What is a zero of this function? You know what? Let's make this f of x. The cube root of 3, right? So let's take this one, set it equal to 0. X cubed is 3. X is cube root of 3. That's a 0. That's fine. But that's not what I want. I want to write it as a series of factors. So what I do is I'm going to do synthetic division with this, but with cube root of 3. So here I want to put cube root of 3. All right? And then here I have 1, that's x cubed, 0 for x squared, 0 for x, and then negative 3. We're venturing into brand new stuff here. 1 comes down. I multiply and I get cube root of 3. So I add and I get cube root of 3. Now, I multiply cube root of 3 by cube root of 3, and I get cube root of 9. Okay? This will be cube root of 9. Multiply cube root of 3 by cube root of 9, I get cube root of 27, which is 3. Add, I get 0. So, yay, obviously, because that was a 0. So now, what do I have? From here, I get x minus cube root of 3. Okay? And then here, look at what I have. I have 1x squared plus the coefficient is cube root of 3 times x. X is outside. Plus cube root of 9. That's your f of x. All right. Last but not least. All right. So this next one, you have to find all the complex zeros of, again, this has to be f of x equals this, given that 2 plus 5i is a 0. So I've given you 1 0. You have to find the rest. How many more are there? There are 3 more for a total of 4. So if that's a 0, what else is a 0? 2 minus 5i. So what we're going to do is synthetic division with the first one, 2 plus 5i. And so it's an imaginary, so it's a complex number. So what? We could still do that. So 2 plus 5i. And then here I get, you know, the coefficients of the polynomial. Leave some space horizontally because, like leave double space. 1, negative 6. 35, negative 50, negative 58. 1 comes down. Now I have that times 2 plus 5i, so it's 2 plus 5i. When I add this way, I get negative 4 plus 5i. Are we cool with that so far? Now, I'm going to multiply that with this. Yikes. Okay, let's just go off on the side here and do that. 2 plus 5i, negative 4 plus 5i. Okay, FOIL. Negative 8 plus 10i minus 20i. Okay, plus 25i squared, which is negative 25. Okay? So how much is that? Negative 33 minus 10i. So that goes here. Let's add. We get 2 minus 10i. So negative 8 minus 25 is negative 33. Okay, so now we're going to multiply 2 plus 5i times 2 minus 10i, and that'll be 4. 10i minus 20i is minus 10i. Negative 50i squared is positive 50. So that's 54 minus 10i. I combined them in my head. So 10i, okay, so 4 minus 20i plus 10i is minus 10i. So here I get, what do I get? 4 minus 10i. And now I'm going to multiply. 2 plus 5i, 4 minus 10i. This is going to be, okay, so 8. Look at what happens here. Something very cute will happen. Minus 20i plus 20i. Oh my gosh. Minus 50i squared, which is plus 50. That gets 58. So you get 0. Who would have thought? Okay, now we have to do it again with the 2 minus 5i. So now we have to do it again with the 2 minus 5i, except, God, please, hang on. Except we have to put these in here now, the depressed polynomial coefficients. We have 1, negative 4 plus 5i, 2 minus 10i, 4 minus 10i. Okay, guys, 1 comes down. 2 minus 5i. 5i's go away. What do I have left? Negative 2. Multiply. Negative 4 plus 10i. Add them. What do I have? Negative 2. All the i's are dropping. Multiply. Negative 4 plus 10i. Add 0. So now what do I get from here? X squared. Okay, so let's write them all down. So I have from the very top x minus 2 plus 5i. Then from the blue, x minus 2 minus 5i. Then from here in the red, I have x squared minus 2x minus 2. And all this has to equal 0 because we want all the zeros. How do we factor the red?
You just x1
Can't factor, it's irreducible. But we gotta find the 0 anyway. What are we gonna do? I wish there was a formula for quadratic functions. There is though. X equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. At the end of the day, I get 2 plus or minus 4 plus 8 is root 12 all over 2. 2 plus or minus 2 root 3 over 2. And we came so far, we can't just leave the 2's in there. 1 plus or minus 1 root 3. So, the zeros are, okay, x equals 2 plus or minus 5i. X equals 1 plus or minus root 3. How many total zeros, guys? 2 and 2 makes 4. No rational zeros. 2 imaginary, 2 irrational, but that's totally cool. Now, I'll take one question and then I have to tell you something else. So technically we solved this problem here. This is it. Benny, did you have a question?
Oh, no, how much time are we going to get on this?
Oh, so it'll all be so that you have 50 minutes. Yeah.
So if we know that 2 plus 5i is given 0 and 2 minus 5i is given 0, can we not like multiply those two together and
No. Because if two numbers are factors, it doesn't necessarily mean that their product is also a factor. Okay, well, no, no, because you have to do it this way. Let me show you the factors of this. So take a look at this one for a minute. Wait a minute. Okay, so these are the zeros. What if I asked you for the linear factors? Huh?
No, because we have.
So the linear factors is x minus 2 minus 5i, x minus 2 plus 5i, and then, okay, look, if 1 plus root 3 is a 0, then x minus 1 plus root 3 is a factor, and then x minus 1 minus root 3 is another factor. Okay? No, you don't multiply it out. Because then you just get the thing back, like the original. If you did for fun, right? Like if you were on a plane ride and like you multiplied all these out, you get that function back. How cool. If you multiplied all these green brackets with each other, you would get that function back.